Hello, everybody. Good morning. Thank you all for joining this webinar about our IP loudspeaker product introduction. So today we will be talking about the IP loudspeaker. I would like to tell you that this webinar is being recorded. So if afterwards you would like to review the presentation, there is no problem. You can simply do that. Also, questions will be answered at the end of the presentation. There is a chat window in the WebEx application, which you can use for posting your questions, and afterwards we will go through the questions one by one. So today I'm presenting here together with my colleagues. My name is Maarten Wings, Public Address Regional Marketing Manager, and I'm here together with Dominic Tripel, who is an application engineer for communication solutions, and together with Jan Note, who is a system integration architect for Bosch IP video systems, as also third-party products. So what we would like to run through today is first to give an introduction about the new IP Horn Loudspeakers. We would like to gain an understanding on what is this product, what are the use cases, and what are the benefits. So topics addressed here, first looking at applications and use cases, then we dive into product details of the various models, then we will have a short demonstration, and then we will have to wrap up with Q&A. So focus applications. Let's start with the IP Horn Loudspeaker, very much in context of a security application. What you, for instance, see here is a perimeter fence, which is being protected by security cameras. And instead of having only the physical alarm follow-up, there is also an option to use a loudspeaker to warn an unwanted person who is approaching the fence. So this is what we see here in the picture. The camera actually has some intelligence inside and is recognizing this person approaching the fence. And there is some scripting running on the Bosch camera. It's called ATSL, Alarm Task Script Language, which allows you to make a virtual trigger towards our IP Horn Loudspeaker, which will automatically play a pre-recorded message to scare off the person who is trying to approach the area. So this is offering a really smooth integration between the Bosch camera and the Bosch loudspeaker, providing you one end-to-end solution for such a security application. So a few more use cases. There is also the option to have live intervention with talkback from the security control room. So in the loudspeaker, there is actually a microphone integrated, which allows you to receive a talkback from the person who is standing near the loudspeaker. And from the control room, there is an option to actually dial the loudspeaker over a SIP interface and then talk into the area. Also, there is a remote speaker test. So why is this? If you have such loudspeakers installed along long perimeter fence lines, who sometimes can be kilometers long, or you have something installed in a smart city concept where the area of the speaker might be far away from the city control room, you would have to drive physically to the loudspeaker if you wanted to test it. So this is very time consuming and not very efficient. So this is why there is a remote test on the speaker. Actually, if you trigger this test from the web interface of the speaker, it will generate a sound. This test sound is actually detected by the integrated microphone of the speaker, which will give you a feedback whether the speaker is producing sound or not. Also, the Ethernet connection is tested, as also the power over Ethernet connection, making sure that the speaker is powered properly. Then there is noise level triggering. So if you have a very quiet scene or area where you usually would not expect a lot of screaming and shouting, or in this example, the band parade just passing by, we can put a threshold level of noise programmed inside the speaker to make it automatically trigger in case a lot of noise suddenly appears. So this especially can help in specific situations where you want to have an automated warning in case something out of the ordinary would happen. Then there is a very helpful feature, automated volume control, which is something very useful in case of an area where always the ambient noise level is changing. So imagine now a busy street. During the day, a lot of traffic. The speaker needs to be louder if it still wants to be heard, compared to the night situation where there is very little traffic on the street and you don't want to have too much sound coming out of the speaker. You want to have the proper volume actually meeting the situation. So this is what the automated volume control does for you. If there is a lot of ambient noise, it automatically will tune up. If the area is rather quiet, then it will automatically tune down, ensuring that you always have a proper speech intelligibility. Then there is direct speaker to camera integration possible if both of the devices are installed on the same pole. So what we can do if we have a camera which has an input and output for audio, we can directly wire it to the speaker, which also has an input and output for audio. So if the operator then talks from the control room through the camera, this voice is actually reinforced or amplified by the loudspeaker, and it can be used to address the person standing in front of it. If the person talks back, then the signal that is captured by the integrated microphone of the speaker can be fed back into the camera and then can be heard on the headset of the operator who is sitting in the control room. Next to that, we have more flexible integration options. So we have a REST API and HTTP API, which allows you to virtually trigger playing pre-recorded messages, but it also allows you to remotely control the volume, the line output, and also the microphone. So this gives you a lot of possibilities. If you have your own security management system and you want to integrate, this is possible on the speaker. Then there is the SIP interface, which allows you to actually call the speaker. So the speaker will have a telephone number in your phone book, and let's call it the gate 21. You then call gate 21 from the phone book. Then you can talk through the phone, through the speaker, into the area of gate 21. So in order to have a proper use case, it's important to realize that we have also the Bosch cameras, of course. Very often these use cases start from a camera point of view. So you want to have a good trigger and good information from the camera that there is something off normal in a specific scene, which is the trigger for the alarm follow-up. So we have a broad variety of different cameras with different form factors, which are running AI-enabled analytics on the edge of the device, helping you to come to a proper use case, having the camera and the speaker all together. Yeah, so we have a few special applications where we have also tuned the analytics of the cameras for specific use cases to make sure that they have optimal performance. So one is, for instance, the IVA, Intelligent Video Analytics Pro building spec, which deals with everything around buildings. So that's parking lots, that's perimeter fences, those are areas around the building where cameras can be used, and also our loudspeakers can be used. Then we have a pack for perimeter fence protection. So this gives you alerts when somebody is approaching the fence or climbing the fence. The camera IVA settings are tuned to the proper setting to have maximized performance for this. And also here, together with a loudspeaker, instead of sending a security guard, you can scare off people by talking through the loudspeaker. Much faster response. Then we have also the environment of the traffic pack. So this is where we have cameras installed near street monitoring traffic, or in a city area where we see streets passing by on cross sections or something like this. So also there where the loudspeaker is combined, if you use this with the video analytics for traffic, you also have a good combination. So this is building security needs, a few aspects which we could find here. So typically security control room, if it is a larger premises, then it's usually on site, can also be remote. And what are typical use cases around the building? You have a perimeter to protect. You have intruders for burglary to detect. Or the parking lot, you could have a theft and loitering. So all of these use cases, which I list here, could bring a trigger to a security management system or could bring a trigger directly to the camera, giving you an automated response or a security control room alarm follow-up. Here is an example of mobile security, which we recently see a lot. So you have a construction site or you have some kind of an entertainment area like a concert or whatever to be secured. So these are areas which need temporarily security. So what we see is that there are companies out there who are renting these kind of mobile security systems, which have some cameras installed and have a loudspeaker installed. So if somebody during the night tries to enter the site and tries to steal valuable goods or assets, then the camera will detect this and there is an automated response from the horn with a potential remote intervention from a security control room. Here an example of city surveillance. So here we have a bar street, for instance, or we have a bus station. Bar street during the day, very quiet. So we have a very low tuned volume. During the night, it is very crowded and there is a lot of ambient noise. So automatically the volume of the speaker tunes up. We see here, for instance, this bus station, so usually very quiet, but suddenly if there is a lot of rioting ongoing, we can have the speaker automatically made an announcement because there is a specific volume threshold being exceeded. We have parking lots areas where loitering could be taking place and where a security control room wants to intervene. So there are many application areas where this horn could be used. Then we have, for instance, the industry area. Also here, perimeter fence protection needed. We have parking lots which are needed. We have large open areas which could be provided here with these type of products. Also here, it can also be used for efficiency use cases. So, for instance, to talk to lorry drivers in case something is wrong with the docks they are approaching. So also here is a nice application example of this equipment. Then we have an application example for remote areas. So imagine there is this remote platform somewhere, very hard to reach. So without installing a lot of equipment, we can put an IP horn loudspeaker on the pole, which can be remotely accessed, and we can dial the speaker and make announcements to persons on the platform who might be in need for aid, or maybe there is something ongoing which needs some intervention, which then can be done from remote. Yeah. So these were the kind of the use cases where we see this product sitting. So what's interesting to understand is, of course, the combination of the Bosch camera portfolio as also the Bosch IP horn loudspeaker. Bosch is in the lucky situation that we have a lot of expertise on both the audio side as also on the video side. So this is something where you can definitely leverage from and bring a combined solution to your customer. So Dominique, product details, I would like to hand over to you.
Thank you very much, Martin. Okay, so hello also from my side. I will show you now some details about the IP horn loudspeaker and about the IP amplifier module. The new SIP-based IP horn loudspeakers are designed for excellent speech reproduction. The housing is racked, water and dust protected, and thus making it ideal for outdoor and severe indoor applications. The IP horn is by standard supplied with a stainless steel mounting bracket. We have two different models, the long throw version with higher output to cover longer distances, and the wide-angle version, which is more compact and thus has a broader coverage. Let's have a closer look at the key characteristics. There is a single cable operation, meaning power, communication, and control all in one cable. DSP with equalizer and presets for music and speech is integrated. We have an internal message storage and also player, a GPIO for control input and output, and line in and line out audio connections. Direct Bosch camera integration is possible with the Alarm TOS script language. Announcements from a SIP-based system with talkback while the built-in microphone is also possible. The IP horn has a built-in microphone at the bottom of the loudspeaker. It can be used for SIP communication and for testing the loudspeaker. Noise detected by the microphone can be used to start an action like playing a message. And it can be used for automatic volume control like Martin described. If the microphone is not needed, it can also be disabled via a switch inside the loudspeaker. Here you can see the back of the loudspeaker with the connectivity details. On the left-hand side is a PUE network port for power, communication, and control. And on the right-hand side, we have a block divided into two parts. First, the GPIO terminal with one GPO and one GPI. And second, the audio terminal with one line in and one line out. Below, so here, we have a on-off switch for the microphone, and there is a physical button for test and reset purposes. This button will perform different actions depending on how long you press it. The IP loudspeakers and the module also can work with PUE and PUE+. Depending on that, we have a different maximum sound pressure level. The IP speaker has a 300 megabyte storage capacity for messages with file formats like WAV or MP3 and so on. Several protocols are supported like NTP, TCP, UDP, HTTP on with Discovery. And the material which the loudspeaker is built of is ASA. So ASA is as tough and dependable as tried and trusted ABS, but ASA is much more UV stable than ABS, so it performs better outdoors. We also have an IP amplifier module. It is a SIP-based IP amplifier module designed as a flexible solution. It interfaces with an IP SIP system on one side and has a low impedance and a line level output on the other side for the connection to loudspeakers directly or via a local amplifier using the line out. It has almost the same key characteristics as the IP speaker, except for the microphone. Here you can see the connection details of the AMP module. So PoE network port for communication and control on the left-hand side, then the GPIO terminal with one GPO and one GPI, the audio terminal with one line in and one line out, and additional the output for a passive loudspeaker, which is only available at the module. Also, the IP AMP module has a physical button for test and reset purposes. The line out is parallel to the loudspeaker output, except you set a manual routing. So if you are calling the module via SIP, it can either be routed to the low impedance output or to the line output and then using a local amplifier. To the low impedance output, 4 to 8 ohm loudspeakers can be connected. Let's have a closer look in the communication path using the SIP interface. So what is SIP? The session initiation protocol is a signaling protocol used to manage, so to initiate, maintain, and terminate communication sessions involving voice, video, and also messages. This application protocol can be used to transmit all types of digital media. So it is a specific technology that can be used for voice over IP. In the IP Horn and IP AMP module, you can create two types of SIP accounts. A peer-to-peer account, applicable for direct SIP phone to IP Horn or IP amplifier module communication, and a registrar account applicable if the IP Horn is connected to a SIP server. Two-way SIP communication is possible with the IP Horn speaker and one-way with the IP amplifier module. Direct Bosch camera integration. What does that mean? You may want to link a Bosch camera to the IP speaker or module so that it plays a message when an action occurs. To do this, you need to create a special API profile and a rule at the IP speaker or module. Then you need to create a script in the camera using the alarm.tos scripting language and configure the areas that trigger the alarm at the camera. So if an alarm occurs in the camera, the script inside the camera will trigger a virtual control input of the IP speaker or module, which starts then playing a pre-recorded message. Here you can see an overview about the VMS integration. So in the first release, it was possible to integration of the IP horn and module in BVMS with scripting for starting pre-recorded messages stored on the IP horn or AMP module. My colleague Jan Noten will show you later some details about this. With Genetec, we have an audio integration of the IP horn and module based on SIP using the Sipilia plugin for Genetec Security Center. So it is possible to do a two-way audio with the horn and a one-way audio with the module. The second release, which is expected for December 2023, will add new functions. It is planned to do a two-way audio from and to the VMS via on-with streaming and back channel, so with BVMS, with Genetec and Milestone. Additional, some advanced SIP features like configurable SIP port will be added, and thus SIP cloud solutions like the one from Genetec will be supported. The existing firmware 1.0 will be upgradable to the new firmware 2.0, allowing products already in the field to use the new features. How can a third-party integration be realized? In a system with many devices, an operator may want to centrally supervise all devices or start actions. A quick and easy way to do this is to share system states over an HTTP API, which communicates between the devices in a system via the hypertext transport protocol. This provides an easy way to collect and process requests. The main function is to set virtual contacts, but you can also read out status information from virtual GPOs, virtual GPIs, or system states like message playing. Before starting the configuration and operation of the loudspeaker and the module, it is advised to download the firmware from the Bosch product catalog and update the firmware using the Omnio firmware upload tool, which is now displayed on the screen. IP address detection can be done using this Omnio firmware upload tool or the Bosch configuration manager as the IP speaker and the module support on with discovery. Log on is possible then with the web browser using the IP address or the hostname. The configuration of the loudspeaker and the module is done via a web-based GUI. So you just need to open a browser and enter the IP address or the host name of the device. There is no default password. This requires you then to register the administrative account for your device. You can use then the overview, which is displayed now, to view four functions like which users are configured, are there SIP accounts, are the messages available, and which rules are already defined. And via clicking on these buttons, you can then jump to these functions. Each tile then displays configuration data and real-time status information of the device. And to access all the functions of the device, you can just use the navigation menu on the left-hand side. I want to focus a bit on a special function of the IP horn, so the device test. The device tests field allows you to perform three different types of tests to your device. The loopback horn mic, which tests the speaker and the microphone. This is only available for the IP horn speaker. Then the Ethernet, which tests the speed of the Ethernet and shows details of the interface. And the power supply test, which tests the actual power supply consumption. You can also activate a GPO action when the device test is active. There is a complete list of states and services available via the HTTP API. So you just need to type in the IP address of the horn plus /API/index.html to get an overview of the possibilities of the API and to test and demonstrate the API. So the HTTP API provides states for like getting and setting virtual GPOs and GPIs, getting system states like PoE state, high memory usage, speaker test, and so on, and also getting and setting controls like user level, mic level, and line level. So this is a very good tool for testing and demonstrating the API, and it helps to understand the way of working and shows the scope of the interface. IP Horn Loudspeaker and IP Horn Amplifier module getting started application note. This application note describes how to get the IP Horn loudspeakers and the IP amplifier module up and running. On the example of the wide-angle IP horn loudspeaker, it is described how to update the firmware and configure some basic use cases like a direct Bosch camera integration using the alarm task script language, two SIP examples, so on peer-to-peer, and how to connect to a SIP server, and how to trigger a message via noise. It is also explained how to test and reset the speaker. The application note can be downloaded from the Bosch website via the product catalog. So just go to boschsecurity.com and navigate to the IP Horn loudspeaker and to downloads. I will show you now some details about the integration of the Bosch IP loudspeaker in Genetec's Sipelia. Genetec is a company with a broad solutions portfolio that encompasses security, intelligence, and operations. The company's product security center is an open architect platform that unifies IP-based video surveillance, access controls, automatic license plate recognition, communications and analytics. And Sipelia is the communication management system that can centralize SIP-based communication in your organization. So it is a module or plug-in of the Genetec Security Center. With this module, Security Center users can make, receive, and manage SIP-based voice and video calls over a network, and thus they can also make a bidirectional call to the IP horn loudspeaker and a one-way call to the IP amplifier module. The Sipelia server is a plugin that must be installed or run on the Security Center server. And the Sipelia client must then be installed on every security desk workstation that needs Sipelia, thus turning the security desk into a SIP client, or you can also call it soft phone. Let's check out a Sipelia example. What is the challenge? Keeping visitors safe within a large building like a shopping mall or a university complex is very important. In case of an event or emergency, control center personnel must react quickly to take the appropriate action to resolve the situation. the market requires a high level of security, and this high level of security is crucial within a large building, and immediate automatically initiated measures need to be executed when required, such as unlocking of an escape door or the issuing of public address announcements. The centralized communication management offers benefits not only for the integrator or installer, but also for the owner or the operator. So when an emergency requires quick action, Sipelia ensures that you have the entire communication infrastructure in place to coordinate the response and keep employees, visitors, and also customers informed. How to initiate a call to the IP horn speaker or amplifier module. You need to open the call dialog in the Genetec Security Desk application and click the Bosch paging zone in the Sipelia address book. In the paging dialog box that opens, you can select the broadcast source which you want to use. For example, the headset for making a live announcement, the text-to-speech function, or you can start a pre-recorded message. Here you can see an example scenario with Sipelia. So a person enters a secured parking area. This is recognized by a camera and displayed in the Security Center application. The camera is associated with the IP speaker. And the security guy has now the possibility to make a live announcement or to start pre-recorded messages. Even text-to-speech transmission in multiple languages is possible. So that's it from my side about Sipelia. More details about the integration of the Bosch IP loudspeaker in Sipelia can be found on the Genetec Tech Hub on the Genetec website. Okay, so I'm done with my part and will stop now presenting and would like now to hand over to Jan Noon.
Yeah, thank you very much, Dominic. First of all, Martha introduced me. I'm from the video systems department, so I'm responsible for the support as integration to third-party applications in large systems. So I'm also responsible for the architecture in large projects where video is used, all our products with integrator applications, hardware and whatever. So all the video systems also supported from the COM BU, so the loudspeaker this time, is also one of these projects that I'm supporting now specifically. And I would like to show you also some video about the EVMS system. So I'm going to first show you something that could help also the COM guys. And that is the app node. And this, can you see that?
Yes.
Okay. The app node is similar actually for the video guys to integrate the loudspeaker into video systems as help in first the salespeople to go to customers and show what we can do with video and COM together integrated in an end user application. Also for of course, application designers, local designers, installers, VARs, or whatever, approach the projects to sell this application, but also, of course, for the after sales people to check if things don't work. This application note, as you can see here in the picture, is based on two things. First of all, the independent integration or standalone integration from a camera addressing the IP Horn loudspeaker. And second, the Bosch BVMS system, the Bosch video management system. And this table of contents shows you what that application note all brings. And I'm going to show later a bit of live demonstration here for BVMS to make it understand how it is all works. I will page shortly through this integration application note. As you can see, it's a draft at the moment, 1.4. Which will be released in a few weeks when the applications are tested also for HTTP connections. The integration here shows you, of course, a bit of the products that can be used, a little bit of introduction, why we have this integration and what can be used as products. Then I think for video people it's very important to understand also the COM product in the field. So for video assistants or integrators who are working to install the loudspeaker, they also have to set the loudspeaker for the integration to be fit. And specifically here, this is the virtual input that has to be addressed and the messages that has to be created. So I have put here some pages that in the horn should be programmed by the installer in the best way, and also doing this as shown here in these screenshots will be applicable for the examples that follow later on in this manual or in this app note. We've tried to put a lot of hints in various chapters of this app note for both for COM but also for the video guys to make sure that they can test, they can set, they can load messages and whatever. So that might be also very handy. Now, as I said, the autonomous standalone system that is actually possible via Bosch cameras, because our cameras have the ability automatically to use the resources from the camera, like inputs and outputs, but also the IVA detections and so forth in the camera to do something with it. And in this respect, it's now to address via an alarm task script in the camera that is possible to implement. And this is then that script in order to let the end user or the installer together with the end user decide what sort of message at which area should sound when this camera itself standalone is used. So there is no operator, whatever. There is only a camera detecting something, and depending on what it detects, we can of course address then multiple messages in the IP Horn loudspeaker. And in the camera, as I said, we have an alarm task script editor and a compiler. So according to that language that's now here highlighted, a certain, for instance here, this is an IVA rule that the camera uses here to address this script, is used here to sound an alarm if a person, for instance, enters a predefined zone or crosses two consecutive lines, whatever you can address in BVMS. In BVMS, so in the ATSL environment, using together all the 8 IVA rules that the camera has, you can combine them here in the script. So to give you a very short introduction here, what we actually do, we send an HTTP command. This is the definition of the HTTP command you see here. That addresses where the port is, where the in the loudspeaker the command should go, and this is going to the virtual input number 1, as you can see here, and it sets it to an on command, so it triggers the virtual input on, and this one does then the off triggering, so to switch off the virtual input. Now, and then here there is some of information here about that. First we use the V-share rule 1, and then we have to do some sort of block generation, switch on and then switch off after a timeout to let the loudspeaker produce the message. Again, there are a lot of hints here underneath, as all these are hints. What if it not works? How do you change to from HTTP to HTTPS, for instance? We have to use authentication for basic authentication in HTTP connections and HTTPS. And here then you see that how you test the total installation. So you have to do a walk test and so forth, and then you can hear if the correct message is produced by the loudspeaker. Also for testing in the loudspeaker, as Dominique already said, we can use the HTTP API for the loudspeaker itself to make sure that the settings in the loudspeaker are correct. And we also had then some hints later or here above for sort of diagnosis for in the camera itself. That is the first autonomous product. This can also be used, of course, in the Bosch cloud environment. In the site itself, you can, of course, have an autonomous camera addressing an IP Horn, which is a cloud camera and loudspeaker setup. The next one is then the integration of the IP Horn together with the BVMS system. In BVMS, of course, we have, like in Genetec and Milestone, we also have the ability for operators to automatically address loudspeakers, but also manually by the operator in his GUI. We'll see that later as an example. First, here I'm going to show you a bit about the scripts that can produce at the moment the messages. One note here. The loudspeaker will be connectable soon in BVMS via the ONVIF protocols. At the moment, we only support in version 1.0 of the loudspeaker, and of BVMS 12, we produce the possibility here to use a client script for the operator, manually addressable messages via his GUI, but also we have server scripted, which then can be used from BVMS generated messages to automatically address a message on the loudspeaker. That's the difference. So this is the operator client script doing it, and for events there is to be used a server script to do that. How to do that, I'm going to show it in the live presentation. I'm going quickly through this all because that is all code and all the things that I'm going to show you live in that demonstration. So this application note is for actually meant and also downloadable for from our portals for installers and all the support guys in both the COM and in the video systems departments to produce their sellable solution at the moment. What I do now, I'm going now to change over to Bosch video systems, BVMS. I hope it's already visible on your screen. Is it, Maarten?
Yes, it is.
Okay. Okay. Then I will show you a bit of this. Quickly, you see here on the left side, you see there the devices, and actually to produce the horn and let it be workable in the BVMS, I will show you that that is not at the moment working. So I'm going to add here. Oh, sorry, I have to go to the device here. Sorry, wrong button. Here, you had the possibility to scan live only on ONVIF encoders, and what you see now on the right side is that the detection on ONVIF already is done properly for the loudspeaker. So if I try to use it in BVMS and I say now next, use it, it asks me for a user at the moment and a password. So, and then you can see that the hourglass here produced a non-connection status. And you also see that message, please authenticate all the device in the table. The authentication here fails, and that's why we cannot at this moment connect to the IP Horn, which will be available by December this year from both COM and from video systems. So another thing that I would like to show also very briefly is here that I told you we have server scripts and client scripts. And for the operator to use these scripts, we have to go to the scripting environment in BVMS. And now a lot of people will say, hey, that is very difficult. I don't understand all this. Don't worry. We also have training in here, but it's a very basic, simple, and applicable by many installers right away. Most of the time, it's simple copy scripts, or you adapt a bit with IP numbers scripts. Here you see actually that we have client scripts already and server scripts. So the client scripts are scripts that the operator will find in his logical tree to operate. So here a message, for instance, do not leave luggage, no waiting zones, and tada, these are the three that are defined in the GUI. I'm going to show that in a minute. And to show you one of these scripts, it looks like a sort of C# programming here, where I use a general activate virtual input process, and here it's virtual input 1 of the loudspeaker horn, and this is then the general script that will do the same as you saw by Assel. It also sends here an HTTP post, as you can see, and I'm using here the DNS instead of the IP the DNS name of the speaker, and I'm going to address here the virtual inputs. And then the virtual input that I generally fire to this procedure, and that's the first parameter in the call, and then this is number 2. The tada is number 3, and we have here the other one is number 1, and we toggle that. That's how it works in BVMS. Server scripts is an equal thing. I can do that here for the server. That's then event driven. That's not operator. So I'm going to switch now to the operator control, operator client as we call it, and you can see here that on the left side is the logical tree with all the devices, and here's the cameras and inputs and outputs, and here you see already that script, and here you also I've added here on a map the do not leave luggage and no waiting zone to show you here a camera. I can drag here in a camera, of course. Also, this is then a camera live now that you can see. I'll wait for the camera and you can see that it is just live. Then I can also here now add a map in here. And let me go to a full screen map. What the operator can do with cameras that are shown here on this airport and are located everywhere, the installer can add these scripts, for instance, do not leave luggage, drag them over here to the other side during installation. So they're fixed now on the map. And if everything is all right, I can click now either here or there to launch a message. Now I'll try to do it now.
In the interest of security, please do not leave your luggage unattended at any time.
So but he can also click here at the waiting zone, for instance, here is the waiting zone of the car park. He can click here.
The areas in front of the arrivals and departures buildings are no waiting zones.
So this is basically very flexible and helpful at any map. Of course, in BVMS we can also stack different maps on top of one another to completely address a building and different levels with loudspeaker messages and whatever. So this is basically what I would like to show you live, and this is going to be better at the end of the year, of course, when we also have this dual way audio. So this was my part of the presentation, and I stop now presentation and go back to Maarten.